All right, guys. Last video was a little bit rushed. Hopefully, this one's a little bit better. And what we're looking at today are permutations and factorials. So we'll talk about factorials for the first time, and we'll look at permutations, which is a huge part of this class. So straight off the bat, in class, you would have played Mastermind. Okay, or we're going to play Mastermind if you're watching this before class starts. So Mastermind's that old-fashioned game where you have, actually, hold on, let me see if I can get a picture of it. Pause. Bam. So there it is. So Mastermind's a game where you have a certain number of colors. This is an old version, I guess. And what you do is this guy here is hiding, and he's got green, blue, orange, and purple. And then the other person tries to guess. And this would have been the first guess over here. And everyone you get absolutely correct. So look in the second row here. You have one orange and one white. And so what's happening here is that orange is in the right spot at the right, is completely in the right spot. That's what gets you that orange peg. And the white peg means one of these other three colors here is the correct color, but in the wrong spot. So see how the purple here is in the wrong spot because this is the thing that the guy chose. So then you go your way through it, and Mastermind, like many things in math, is based on, like many games, is based on the math of probability, okay? So, and counting. So our simple today's version, and if you go, wow, that's kind of boring, but we'll make it more complicated as the class goes on. You can have a red one, a green one, so a red dot, let me see if I got all these colors here, a green dot, a yellow dot, and we'll go B stands for blue. It doesn't really matter, but we'll go with blue dot. And then you put them in any order. And the question is, how many different orders can you have? Okay, so how many different combinations can be made? And the way we approach this is we say, let's look at the different slots that you're going to go into, the first, the second, the third, and the fourth. So what happens is you ask yourself, how many options do I have for the first slot? Now, it doesn't matter at all that this slot is the first one we're looking at, because if we said, let's look at this slot here first, the same math would apply, okay? But we'll start left to right, because that's kind of how we set this up. And we say, how many different options do I have for the first spot? And I have 4, okay? I have 1, 2, 3, 4. So let me just choose. So I have 4 options here. And let me choose one of them at random. I'll just choose green first. So green is gone. Now, in this version of the game, we're going to say you cannot repeat what you just selected, okay? You have to choose something different. So green is gone. So now in the next spot, I can choose from red, yellow, or blue. So that's 3 spots. And then let's say I chose yellow. Then I'm left with red and blue. And I chose red next. And then that's gone. So I had 2 options there, and it's gone. And now I'm left with just the 1. So we learned from the fundamental principle yesterday that to figure out how many total ways you can come up with this, or different options there are in this game, you're going to multiply the 4, the 3, the 2, and the 1. So in general, we said m times n. We also took that a step further by saying if there's more than one option, so we have the tree and 2 options and 2 options, you go 2 times 2 is 4. But as you move on with more branches of the tree, you just keep multiplying. So what would happen if we added a 5th color? That's the question. So the 5th color, again, you're just choosing 4 of the 5. Okay, so the game's set up that way. You're going to start with a 5, and then a 4, and then a 3, and then a 2, and you multiply those up. Okay, so that's our little intro to what we're looking at today. So factorial, what's going on here? Factorial is this. So this is not an exclamation mark, right? This is when you write this, n or anything with the exclamation mark behind it, it is, what that means is take that number and multiply it by every number after it, or smaller than. So for example, 3 factorial is 3 times 2 times 1. That's 6. Okay, 5 factorial, 5 times 4 times 3 times 2 times 1. 7 factorial divided by 4 factorial. So I'm going to expand this here. And when you divide, and we will be dividing factorials as the class goes on. So on the bottom, there's 7 factorial on the top. On the bottom, you have this, 4 factorial, 3 factorial, 2 factorial, 1 factorial. So this looks a little funny as far as division goes, but that's what's going on here. And the one thing about this is you can go ahead and figure them all out. But the one thing about when you divide by factorials, you can, when there's a bigger number on top and a smaller number on the bottom, what you notice is here it's 4 times 3 times 2 times 1. So you can actually cancel these out because 4 divided by 4 is 1, 3 divided by 3 is 1, and all the way through. So when you have this sort of thing, you can just figure out 7 times 6 times 5. Kind of neat. Okay, so that's factorial. And that leads to, if we go back to this question here, this answer here is 4 factorial. 4 times 3 times 2 times 1. Okay, so that's that. No, this is driving me nuts today. All right, permutations. Permutation. Hold on, let me try something different. A permutation. Am I on the wrong page now? Hold on. Yes. Okay. Patience. Oh, it's an embarrassing technical problem. Anyway, a permutation of a set of objects is an arrangement or ordering of the objects. Order matters. Okay, so in that case, up above, when we had our first color, whatever that was, I think it was yellow. Yellow is first. It's not just somewhere in there. It matters that yellow is first. Okay, so again, order does matter. So why, if you go, of course, order matters in these things. Again, it's the question I've asked you guys before. If you have a bunch of kids in the class, right, and you have all these guys in the class, and you say, I want to take 2 kids out and just have them do something together, then order doesn't matter. If I say, hey, I'm going to take Billy and Fred come here and go do something for me and do it together, order doesn't matter. But if I'm saying, hey, I want 2 kids, one goes upstairs, one goes downstairs. Billy, Fred, selecting them that way, Billy and Fred, is different than selecting Fred and Billy. So in permutations, order does matter. It's a question like this. Okay, the number of permutations of n distinct objects is, in fact, n factorial. So if you have n things to line up, the number of permutations is n. So if you look at that question above, the mastermind situation, right? You have the 4 different colors, and how many different ways can you line them up? 4 times 3 times 2. Okay, let's do some examples. If I'm going to visit 8 clients, I'm a salesperson, and I want to go around and visit my 8 clients, how many different ways can I visit them? Well, it's going to be 8 factorial different ways. It's 8 times 7. So if I have my different clients, client A, client B, client C, D, E, F, G, and H, okay, that happens to be their names, which is kind of weird, but those are the names, and I want to figure out how many different ways can I see these people. Well, there's tons. There's actually 8 factorial, 8 times 7 times 6 times. And why is that the case? Well, who am I picking first? I have 8 options for the first person, so I'm going to see F first, and then second, who am I going? Okay, now again, it's different because F, we have to note 2 things. 1, the order matters, that's the question, and 2, I can't go see F again. It's a different question if order doesn't matter. It's a different question if I can go see F again, but I can't. F's done. So who do I see next? D. Now, how many are left? 6 and 5, and I keep crossing out until I keep going. Okay, remember that the dot there is not a decimal. It's a multiplication sign. Example, if you and 4 friends, so it's you and 4 friends, be careful with the wording, are going to a theater, and how many ways can you sit? So you're going to sit, you have a little 5Z seat section here. They got reclining seats these days because the world's nuts. And you want to sit in order, okay? And there are 5 of you, and your names happen to be A, B, C, D, and F. Not E. E wasn't invited. You should stop talking during the movie. Actually, I don't get invited to movies because I talk too much, but that's a different thing, okay? So let's go through this, and the 5 of you are going to line up. How many different ways can you line up? Order matters, right? Are you here? Are you there? Are you there? Are you there? Are you there? It's completely different things, okay? And the answer for this, since there's 5 friends, 5 people, is 5 factorial. Let's go back and look at Mastermind. If in the real game there are 8 colors, how many combinations of 4 are available? Okay, so that is based on, we can answer this question 2 different ways. One is using the fundamental counting principle from yesterday, and the other is using factorials. So the fundamental counting principle kind of works on, basically it's working on a tree. So if we made a tree, we're not going to make this because it's going to be crazy, but if we made a tree talking about this crazy new mastermind where there's 8 colors and I choose 4, the first round, so round 1, would have 8 branches. So I have 8 different colors, okay? And then after that, because I can't repeat, once again, you can't repeat your colors, you would have 7 choices, okay, because 1's gone. And for each of these, there'd be 7. So this would be a crazy looking tree. And then 6, and then 5. So using the fundamental counting principle, I have 8 options for the first choice, 7 for the second choice, 6 for that, and 5 for that, for the 4th choice. Okay, so 8 times 7 times 6 times 5. Using factorials, okay, and this leads to the next thing. Using factorials, you could ask we're going to look at, let me look at this first and I'll come back up here. Using factorials, the number of permutations of R items out of N items is N factorial divided by N minus R factorial. Now this example here is going to be a little different. So let me just look at this here. What that is saying is, if we want to use factorials, it's going to be 8 factorial. I'm choosing 8 sorry, I'm choosing R objects out of N, which means I'm choosing 4 objects out of 8. So I want to choose 4 out of 8 to line them up. And the answer is 8 factorial over 4 factorial. Okay, so when I look at that, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. Now, this wasn't the best example because let me figure out how I got this here. This is not this 4. This is 8 minus this 4. Okay, so I'm choosing 4 things out of 8. So what number goes down here? It's 8 subtract 4, which happens to be 4. A better question, and I'll probably change this for next year, is if there were 9 colors that I'm choosing for. If there are 9 colors that I'm choosing for, you don't put the 4 down here. That's wrong. Okay, what you do is you say there's 9 factorial on top, and on the bottom it's going to be 9 subtract 4, which is 5 factorial on the bottom. Okay, so this 4 here, a little misleading. Just be careful about that. Okay, and I'll probably change this in your note actually. So 8 times 7 times 6 times 5 times 4, that, okay? And then, but let's clean this up. That crosses out with that, and I'm left with 8 times 7 times 6 times 5. And that was what I did with the fundamental counting principle. Okay? So when we are choosing 8 out of 4 things, the way we would write that is you go like this. You write 8p4, and that means a permutation of 4 things out of 8. Okay? And that is another way to write it, and that's how your textbook writes it. Underscore, like lowercase little tiny 8s and R's. So if you see this, what does that mean? That means I'm choosing 3 things out of 5. How many ways can you choose or line up 3 out of 5 things? So if I have, back up top, if I have your 5 friends, you and your 4 friends go out for something, for the movie, okay? And then 3 of you are then going to go to get popcorn together, okay? No, sorry, that's a bad example because well, let's redo this. You got your 5 friends, and now 3 of you are going. I've got first class seats. You just won first. Congrats, okay? And you're going to go line up in the front, and in the front first class seats. And the question now is, how many different ways can you choose? And the seats are different. Okay, there's a seat here, a seat here, and a seat here. They're all different. Okay, how many different ways can you line up these 3 people out of the 5? What you're going to do is say, I have 5 options for this first spot, 4 options for this spot, and 3 options for that spot. 5 times 4 times 3. Okay, how do you do that like this? With so 5 times 4 times 3 is basically that's the fundamental counting principle. How does it relate to this? Well, this is telling me that I have 5 factorial over 5 subtract 3 factorial, which is, let me rewrite that, 5 factorial over 2 factorial, which is 5 times 4 times 3 times 2 times 1 over 2 times 1. That cancels out with that and I'm off with that. Okay, so that's how we do permutations. Describe a situation where this could apply. I'll let you do that on your own. So you want to line 2 people out of 12 and order matters. How many ways can 8 racers win gold, silver, bronze? It's a classic math question. Okay, so you have 8. So here I want to order matters. So it's a permutation. 8, and I'm choosing 3 of them. So I go 8 factorial over 8 subtract 3 is 5, 5 factorial, and then work that up. Okay. Next up, restrictions. So here, let's look at this here. And how many ways can 11 friends be seated in a line if Susan and Lisa must sit together? This is a great question. So if you look at this question here, and I'm going to line up 11 people. So normally it's 11 factorial. And then you say, no, Susan and Lisa must sit together. Well, this is a really cool question because you have this scenario here where you have 11 friends and you actually treat Susan and Lisa as a single entity. So you're not lining up 11 people. Okay, you have person, Susan, Lisa. Okay, where does Susan, Lisa go? That's the question. Does Susan, Lisa go first, second, third, all the way down? So if you have 11 spots, they can go here, they can go here, they can go here, they can go all the way, but they can't start off at the end. They can't start off in 11 spots. So they actually can start off in 10 spots. Okay, so one way to look at it is say, let's see Susan and Lisa first. There's 10 spots for them. Okay, and once they take up 2 spots, because don't forget there are 2 people, there are now 9 friends left to order. So from then on, it's 9 factorial. Okay, so it actually, which is the same as just saying 10 factorial. So one way to look at it is like that. Another way to look at it is just say, hey, Susan and Lisa now are this new entity called Susan Lisa, or Suli, or something like that. I don't know. Or maybe they just came up with a new name. I don't know. They know them all. Okay, so they can be lined up in 10 factorial ways. But the issue with that, though, is that's if Susan goes first and Lisa goes second. So the one thing you're going to have to do is add to that 10 factorial different ways where Lisa's first, LS. Cool question, eh? Okay, I'm almost out of time. Check these questions out. We'll do these in class, and hopefully they make sense. Okay, take care. Bye.